Hello guys, in today's lesson, you're going to be looking at the derivation of linear and angular velocity. In our previous lesson, we derived linear and angular displacement. So today we're going to be looking at linear and angular velocity derivation. So how do we derive the two of them? Quickly, let's have an analysis. Now, this is a uniform circular motion, not only uniform, let's say horizontal also, using the format. Don't forget, these formulas we're deriving are basic formulas. These are not complex ones. We're going to derive all the very basic ones, which will help us derive the complex ones easily. So how do we derive this? Now, this one we have here, this is a circle here. We have radius, don't forget. Now, at this very point in time, at point A and then at point B, at point A, this body moves with this speed. Then at point B, this body moves with this speed. Now, don't forget something. When we discussed the uniform circular motion, it is said that for uniform circular motion, although the speed is constant, we're not discussing speed here. We're talking about speed. Speed is just the distance all around. We're not talking about speed. We're talking about vector quantities here. So we're talking about two things. First of all, velocity, which is this linear velocity, and also we're talking about angular velocity or centripetal velocity. So as you can see, the major differences between them, or one of the major differences, this one mainly cares about the movement of the body about an axis. This one cares about the angular movement, the speed at which the body rotates. That's what this one cares about. That's what this one's all about. Why this one does not really care much about the speed at which the body rotates, it mainly cares about this, the speed or the velocity of this very body at every edge. Let me say at this very spot, the body is coming with this crazy speed, if not for a kind of force called centripetal force that keeps it going. So the very spot also, the body is moving with this speed. Look at its faces like this, about to go out like this, where a force keeps it back in motion. That's linear speed or linear velocity. I mean, you talk about velocity, but this does not really care about the does not care about this does not really care about the speed of the body or the velocity of the body at different edges. It only cares about just the speed of the body in the circular format, the angular speed. So that's one of the major difference. And also one major thing is this two here, this at this point and also at this point, they are constant, but there's a change in direction. But we don't really have that here. We don't have that for angular distance. Just what we have. So let's simply derive the major formulas. So we have an angle here, which is mainly in radians. The angle is very, very tiny. And also it's the same thing as the angular displacement. It's in an angular displacement. So first of all, we're going to